Hello viewers, here is Dr. Mala Sharma. Welcome you to my channel MALACHEMPHILIC. Let's start video number 84. Video number 84 is the 26th episode of Chemical Thermodynamics. And topic of this episode is limitations of first law of thermodynamics. So let's start. We know what is first law of thermodynamics or what is given in the first law of thermodynamics. First law of thermodynamics tells that energy cannot be created nor be destroyed, only it can be transformed from one form to another. That means when one form of energy disappears, equivalent amount of another form of energy reappears. Okay? And first law of thermodynamics, that's why it is known as law of conservation of energy. And more precisely it is told law of conservation of mass and energy. All these things I have discussed in my earlier videos. Now let's see what all things cannot be explained by first law of thermodynamics, or more precisely what all information we cannot get from first law of thermodynamics. See, number one, it imposes no restriction of heat to work relationship as to the source of heat or on the direction of its flow, as long as the total energy of the system and surroundings remains constant. What does it mean? Let's see with the example. See, you have some water in a container which is say at room temperature. Now, in another container, bigger container, you have taken some water which is at higher temperature. Here it is room temperature. Room temperature means we consider 25 degrees centigrade. Now this water is say it is 60 degrees centigrade. Now this water, that means this container with this water, if I keep it in this container where you have water at higher temperature, then what will observe? This water which is at a room temperature, it will be warmed up or it will be heated up. Why? It is taking heat from this high temperature water and slowly it is heated up. That means here if I consider this is my surroundings, that is this high temperature water is my surroundings, then my system, that means water at room temperature, system is absorbing heat from the surroundings and getting heated up, and that we observe it occurs spontaneously. But first law of thermodynamics does not tell whether this high temperature water will release heat or this water which is at lower temperature comparatively, that will release heat and high temperature water will absorb it. Let's take another example, then it will be more clear. Say for example, here in another container, instead of water we have taken ice. This is all ice. Ice means 0 degree centigrade. Okay, this is ice, and this water which is at room temperature, this container I kept it here. Now first law of thermodynamics cannot identify whether this heat will be provided from this ice to this water which is at 25 degrees centigrade, or heat will flow from this ice to water, or from this water to ice which is at 25 degrees centigrade, that from water to ice. According to first law, either system will release heat, this surroundings, this is my surrounding, this ice, this is my system. System will release it, surrounding will absorb, but total heat of the system and surrounding will remain constant. Or surrounding will release it, system will absorb. That means as per first law, there is no distinction whether this water will release heat to this ice so that ice will melt, or ice will release heat to this water, so that this water will absorb heat from the ice and become warmer, and this ice will become much more colder. That distinction part is not given in this first law. That means, what is the source of heat? Here the source of heat is from high temperature water to low temperature water, which occurs spontaneously. All of us know these things. Okay, but this first law cannot identify that. First law takes any one, either system will release it, surroundings will absorb, or one body will release it, another body will absorb, or the surrounding will release it, system will absorb, but total heat of the system plus surrounding will remain constant. That is given is first law. So here in this case, according to first law, it may also happen that ice is releasing heat, so that this water at 25 degrees centigrade, it is getting heated up and ice is becoming more and more colder. That is also possible. But in practice, we know that spontaneously from this hot water or heat will flow from the hot body to the cold body. Okay, this heat will flow from this hot water to the ice, so that ice will get melted. That will our observation. That is all this spontaneous process, or what we observe in our daily life. Okay, real life we observe that. So that distinction is not given in this first law of thermodynamics. That means it cannot tell about the source, which one will release heat, either ice or this water. Otherwise, which direction heat will flow? Heat will flow from the hot body to cold body. If system is hot, from the system it will go to the surrounding, cold surrounding. That distinction part or that identification part, that means the source of heat or this direction of flow of heat is not given in the first law of thermodynamics. Okay, let's see the another one. No information about the spontaneity. What is spontaneous process? All natural processes are spontaneous process. What is spontaneous process? Spontaneous process means which occurs without the help of any external aid. That is spontaneous process. Whenever you are making a process to occur with the help of any external aid, external support, that is not a spontaneous process. Right? Say for example, all of us know that water falls from high altitude to low altitude. That means that is high level to low level. Direction of flow of water is, this is water. Water is always from high level to low level. Okay, this is the spontaneous process, natural process. Okay, but if you want to take water from the high level, water from the low level to high level, this one, low level to high altitude, that you cannot do it spontaneously. It does not occur spontaneously. You have to use the pump to take water from the low level to high level. That means external aid. But what first law of thermodynamics tells? Okay, when water is falling from high level to low level, its potential energy, initially when it is in high level, it has the potential energy due to its position. Potential energy is converting to kinetic energy. Finally, when it is touching the ground, because of the friction, there what happened? Here you'll have the heat energy. Heat energy may produce. Okay, this is the energy transformation. So energy will be transformed from potential energy to kinetic energy. Finally, it may be to the heat energy, but total energy remains constant. And from here also, if this water flow from lower level to higher level, then also according to first law, energy transformation is kinetic energy will be converted to, here it will be its potential energy. Kinetic energy will be converted to potential energy. Here when it is flowing, it is here the kinetic energy. Okay, this transformation of energy occurs. But we know water on its own cannot flow from low level to high level. That means that is not the spontaneous process. You have to use the pump, where you have to give the electrical source or electrical power. That electrical energy will be finally converted to the potential energy. That means that electrical energy will make the water to flow. That means that will be converted to kinetic energy, and finally when it will reach the high level, it will be the potential energy of the water. But that you have to supply from outside, external aid. So it is not a spontaneous process. So no information about the spontaneity. Take another example. Say here we have a metal bar. Okay, this is one end. This end is hot end. This end is hot and this end is cold. Okay. Now what happened? Spontaneous process, as per our experience, we know that heat will flow from the hot end to cold end. Okay. But according to first law, heat will flow, it may flow from this direction to this direction, or from this to this direction. That means one end will lose heat energy, other end will absorb. So if hot end loses energy and it flows to the cold end, then here the temperature will decrease, here temperature will increase. But from the cold end also heat may flow to the hot end. In that case, cold end will become more and more colder and hot end will become more and more hotter. As per, there is no distinction as per first law of thermodynamics. First law of thermodynamics is not telling, it is telling one end will release heat, another end will absorb, but total energy remains constant. So here total heat energy remains constant. But it is not telling whether this hot end will release energy and cold end will absorb, or cold end will release energy, hot end will absorb. That distinction is not there. That means it is not giving any information regarding the spontaneity, which process occurs spontaneously. Now, as we deal with the chemistry, let's discuss some chemical reaction. Okay, in first law of thermodynamics, we have seen one thermodynamic quantity that is called the enthalpy, which is denoted by H, right? And enthalpy is the total heat content of the system. Already I have discussed all these things. And when this enthalpy change, delta H, that is negative, means that heat energy is released from the system, given out from the system, and delta H positive means the heat energy is absorbed by the system, right? Now you see, and when the heat energy or energy is released from the system, then it gains the stability. We know that energy and stability are inversely proportional. If the energy is decreased, stability will be more. So in that case, the reaction where the energy is decreased, that means exothermic reaction where energy is released, those reactions may be spontaneous reaction, or those reaction may occur spontaneously. According to first law, this can be explained that exothermic reaction where energy is released, those reactions can occur spontaneously because energy is released, delta H is negative, heat content or enthalpy change is negative. So energy is released means it is going to the stable state. Any system wants to go to the stable state spontaneously. So exothermic reaction may be spontaneous. Okay, let's say for example, we'll take one reaction, calcium oxide plus water, and this will give you the calcium hydroxide. This is your exothermic reaction, aqueous solution. This is your exothermic. Exothermic means here your delta H, that will be the negative. Energy is released. So system is going to the more stable state. So it is spontaneous. Fine. But melting of ice above 0 degree centigrade temperature, that is also spontaneous process, but their energy is absorbed. That means delta H is positive. Then how come it is spontaneous? Then dissolution of sugar in water. There, that is also endothermic. That means energy is absorbed, but that is a spontaneous process. Then how come it is spontaneous? Then take another example. Say this one. Hydrogen plus iodine. This reaction 2Hi, and this here also delta H is positive. That means energy is absorbed. That means endothermic. Endothermic means it is more energized. It is not going to the stable direction. Then how come it is spontaneous? So only this term, that is enthalpy or heat content, cannot predict the spontaneity of the process or reaction. Okay, so some other thermodynamic quantity is required. Thermodynamic term is required to explain the spontaneity of the process of the reaction. This is only this enthalpy change is not sufficient. So this is the second drawbacks or second limitation of the first law of thermodynamics. Now third one, no guidance on efficiency. According to the first law of thermodynamics, when energy of any form disappears, equivalent amount of energy of other form reappears. Okay, that means energy can be transformed completely from one form to other. Okay, but heat cannot be completely converted to mechanical work. There is no machine which can completely convert heat into mechanical work. Any machine, it can convert a part of the absorbed heat to the mechanical work, and remaining part it releases in the sense it increases the randomness of the system, which we know, which is called as the entropy of the system. That is another thermodynamic term that is introduced in the second law of thermodynamics. Okay, so if you take any machine which is converting heat into mechanical work, if it absorbs Q2 amount of heat, then Q1 amount of heat, it goes to increase the randomness or disorderness of the system. That means this Q1 is not converted to mechanical work, divided by Q2, that is total heat absorbed, that is known as the efficiency of the machine, which is denoted by eta. So no machine is 100% efficient. No machine can convert heat completely into mechanical work. A part of it goes to increase the randomness of the system. So from first law of thermodynamics, we don't get any guidance about the efficiency of the machine. This efficiency of the machine, this part comes in the second law of thermodynamics. Okay. Now, next one, then as I told you that a part of the heat is converted to mechanical work by the machine. Remaining part goes to increase the randomness or entropy, which is not given in the first law. So, fourth drawbacks or limitation in first law of thermodynamics is no insight into entropy. So, only the enthalpy change or heat released or absorbed, this part is not sufficient. Okay, it's not, already I told you, enthalpy part not sufficient to predict the spontaneity of the reaction or process. Okay, so another term which is entropy, which gives the randomness of the system. When entropy increases, randomness increases. That is also required to predict the spontaneity of the process of the system. Now let's see. Suppose this is solid. Solid means molecules will be close to each other. Okay, close to each other means strong intermolecular forces of attraction is there. Now when solids melts, this is melting. solid melts, it becomes liquid. Liquid means molecules will be little away from each other. That means this intermolecular forces less compared to solid. They are away. That means randomness increases. This is a ordered condition. This is little bit disordered. So here entropy increases, and this occurs spontaneously. Okay. So in the spontaneous process, randomness increases. Now if it vaporization, then what happened? Then it will become gas. Molecules will go far apart from each other. Intermolecular force of attraction practically nil. Okay, that means randomness is more, and this process also spontaneous. So in the spontaneous process, all natural processes are spontaneous. In the spontaneous process, randomness increases. That means entropy increases. Now take another example. Say this is a solute, say sugar molecule. Okay, this is a solute which is added to a, these are my solvent, which is added to solvent. Okay, now these are the solvent molecule, right? Now when you have added the solute to the solvent, now solid molecules are in ordered condition, solvent molecules are in ordered condition. Then dissolution start. If this solute dissolve in the solvent, sugar dissolve in water, then what will happen? There is a random arrangement. So this is one sugar molecule, one solvent molecule, sugar molecule, solvent molecule, solvent molecule, sugar molecule, solvent molecule, sugar molecule, sugar molecule, solvent molecule, like that. That means a disordered arrangement, random arrangement between the solvent and solute molecule. Solute molecule goes inside the solvent and a random arrangement. So here this ordered arrangement destroys. So entropy increases, and this is a spontaneous process. So to predict the spontaneous process, this once again I am telling, enthalpy change is not sufficient. We have to consider this entropy change also. Okay. Later we will come to know other thermodynamic terms. So far we know that this first law of thermodynamics cannot give us certain information. First one, what will be the source of heat, what direction the heat will flow, that it cannot tell with proper clarity. It does not give us any information about the spontaneity of the process. Okay, and it does not give any information about the efficiency of the heat engine or machine. No machine is 100% efficient. It can convert some amount of heat to mechanical work, but not 100%. There is no information about the, or no guidance about the efficiency of the machine. And finally, no insight into entropy of the, or entropy change of the system. So all these things will be explained in the second law of thermodynamics, which we will discuss in my next video. Hope you have understood. Thank you.